Hi guys, and welcome to the final lesson in the sequence of lessons on surds. Today we're going to be looking at how to rationalise the denominator. Now this is going to bring forward all the skills that we've done in our previous two lessons on how to simplify a surd and then also operating with surds. You will need a pen and paper for today's lesson because there will be some activities to do later on, and they will generally stem from the website hbkportal.co.uk/mwb/home. The link is in the description. However, when we get to it, I'll display the questions on screen and you can do those questions from there. Or if you actually wanted to focus on a particular star because that's what you're really struggling with in terms of level of difficulty, it might be worth having that website open in a separate tab. So to think of all the skills that we are meant to be bringing forward into today's lesson, well, the first thing is that we'll need to simplify any one of these questions here. The first one, the square root of 80, we can split this according to the rules that we picked up earlier this week into two numbers. One where it is a square number and the other it can't be square rooted or something like that. So ideally we're looking for the highest square number that goes into 80, and this number is then 16. So you can try this on your calculator. The square root of 80 will give you exactly the same answer as the square root of 16 times by the square root of 5. But the idea is that we're simplifying this, and you can see here that the one number that can be simplified is the square root of 16, so the square root of 80 could be written as 4 root 5. We also picked up that when we were operating with surds, that if I'm timesing a surd by itself, then we can have the square root of 5 times the square root of 5, and it will then give me 5. When we are looking at expanding brackets, we still use the claw method or grid method, whichever technique you would like to use. And by all means, if you're struggling with this aspect, please do look out for the video that was launched earlier today on expanding 2 or more brackets. Here I'm going to use the claw method, and the first thing I'm going to do is root 5 times by root 5. So this, when I'm expanding it, gives me that. However, we've just seen that root 5 times root 5 is 5. So we'll then carry on that if I've times root 5 by root 5, I've also got to times root 5 by negative 3, and that will give me minus 3 root 5. So I've times everything in this second bracket by root 5. I now need to times everything in that second bracket by 3. So begin with 3 times root 5. That will give me 3 root 5, and then finally we've got 3 times minus 3, which would then give us negative 9. Now from all of this we can see that there are certain things that will collect together simply because they are like terms, and here we've got negative 3 root 5 and 3 root 5. These two together make 0, so they cancel out, and then I've just got 5 minus 9, which would then give me negative 4. So this one's quite an interesting one because although we ended up, we started with a surd question, we actually end up with just a whole number at the very end. So it's an interesting one to look out for the rest of today's lesson. So what is the whole rationalising business all about? Well, we've got to remember that a surd is an example of an irrational number. And an irrational number is one that is written in a square root form, where its decimal equivalent will basically go on forever, and we don't want to write this in as part of any kind of calculation because it would look rather messy. And to be honest, whenever we leave something in surd form, it is always going to be the most accurate form that you could possibly give an answer in. So what we mean by rationalising a number is to basically get rid of the square root. And we saw just a moment ago that if we had root 5, I can times it by root 5 and get 5. So when we're thinking of this type of question, and we've been presented with, well, rationalise a particular number, really, and if it's a surd, times it by itself. So root 7 times root 7 would give me 7. What would be more interesting though is to look at questions like this, where I've got an expression and I've got 1 plus root 5, and the answer to this is very similar to what we saw a second ago in those examples. So just quickly scanning back, we saw that if we had root 5 and 3, and root 5 minus 3, it's simplified to give us negative 4. So what if I had 1 plus root 5? What is it that I could multiply this by and end up with just a whole number? The answer is 1 minus root 5, because when we start expanding it, 1 times 1 is 1. 1 times negative root 5 is negative root 5. Root 5 times 1 is positive root 5, and root 5 times negative root 5 is minus 5. And you'll notice that when we look at this, it can be simplified down through 1 minus 5 is negative 4, minus root 5, add root 5, they cancel out. So my answer is just a nice easy number. So what if this question was presented in a slightly different way, and we had a question that looked something like this? And this is where I want to move into some examples of how we can actually rationalise just the denominator at this point, so that I can actually kind of look at it in a more traditional fraction form where the denominator is a whole number. So let's use some of these examples in order to now work through and gain a better understanding about how we rationalise the denominator. Okay, so looking at some of these examples then, let's move on to my sketch pad and have a look at the first one. If I've got 1 over root 5, I need to make sure that whatever I do to the denominator, I do to the numerator. So we know that in order to rationalise the denominator, I times it by root 5. But whatever I do to the bottom, I have to then do to the top. So what I get is root 5 over root 5 times root 5 is 5. I've done what the question has asked. I've rationalised the denominator, which is fine at this point, even though there is a surd still within my fraction. Number 2. What if I had 3 over root 3? Now, in the same way as we got rid of the root 5 in the previous question, I'm going to times the surd by itself. But whatever I do to the bottom, I then have to do to the top. So on the top, I then get 3 root 3. And on the bottom, root 3 times root 3 is 3. Now here we've got an example of a question that results in a fraction, but the fraction itself can then be simplified. So in this case, 3 divided by 3 is 1, so we then end up with root 3. Moving on to question 3. If we've got 1 over 1 plus root 5, we saw in our previous example that in order to rationalise a number where we've got 1 plus root 5, I would times this denominator by 1 minus root 5. Whatever I do to the bottom, I then have to do to the top. Now because I had a numerator of 1 before, I'm just simply timesing 1 by 1 minus root 5. So my numerator is nice and easy, 1 minus root 5. But the bottom, I now need to use the claw method in order to be able to expand this out. So I'm going to multiply everything in the second bracket by 1, and times everything in the second bracket by root 5. As a result, I get 1 minus root 5 plus root 5, and root 5 times negative root 5, a positive and a negative would make a negative, so that would give me minus 5. I can see that the middle two terms in my denominator will now cancel out, so I can cross those out and now simplify it as being 1 minus 5. In this case, I will get 1 minus root 5 over negative 5. Now I don't particularly like the fact that I've got a negative number on the bottom, so what I'm going to do is times both top and bottom by negative 1, and it would basically change the sign of every number within the fraction. So negative 1 add root 5 all over 5. And that's how I prefer to leave this question. Obviously on the numerator I could switch the root 5 and the negative 1 over if I wanted to make it look a little neater, but I kind of don't mind at this point. I have rationalised the denominator and I have made sure that it is positive. So moving back to some of the questions that I'd now like you to have a go at. This is basically, I've modelled the learning that I'd now like to show through answering these questions. Okay, so I'm going to give you about 3 minutes in order to have a go at these 3 questions. As much as possible, simplify where you can, and I'll go through the answers in 3 minutes' time. Off you go. Just over a minute left. Okay, so let's go through the answers. So with the top one, I want to make sure that whatever I do to the top, I do to the bottom, and in order to rationalise the denominator at the bottom, I need to multiply it by root 3. So timesing both top and bottom by root 3, I will then get the answer of root 3 over 3. Moving on to the next one, I need to times the bottom by root 7, so timesing it by itself, timesing the top and the bottom by root 7, I get 7 root 7 all over 7. And like with my example, here I've got a common factor of 7 in both the numerator and denominator. So 7 divided by 7 gives me 1, and that will just leave me 1 root 7 left over. For the last question, we need to think about how we can rationalise the denominator where it is 1 minus root 7, and it's not just the surd that's by itself. If I was to times it by itself, it wouldn't get rid of a surd, it would just make it more complicated. So for this one, I need to multiply both the numerator and denominator by 1 plus root 7. In which case, my numerator, simply because it was 1, and I've got one lot of 1 plus root 7, it will just be 1 plus root 7. However, using the claw method on the denominator, everything in the second bracket, first of all, needs to be times by 1, and then everything in the second bracket needs to be times by minus root 7. So in this case, I will end up with 1 times 1, 1 times root 7, negative root 7 times by 1, and negative root 7 times root 7 is minus 7. So now we end up with 1 plus root 7 as my numerator, and after I've cancelled out the middle two terms, 1 minus 7 is negative 6. Now I don't like the fact that I've got a negative number on the bottom, so I'm going to times the top and bottom by negative 1, and I get minus 1, take away root 7 all over 6. Okay, so we've now gone through a number of questions. Each of them relate to how we can rationalise the denominator, but we've kind of built up, hopefully, a bit of knowledge on a lot of the basics. Now what I want to do is move on to the MWB website now, where if you've clicked on the link in the description or you've searched for it yourself and you've got it open in a separate window and still able to watch the video and also have a go at your own questions, I'd like you to, in the search box, just simply type in surd. We've gone through how to simplify a surd, operate with a surd, and we are now moving on to rationalising the denominator. I'm going to select the single star, and the idea is that we can work through a range of these questions in your own time independently and see how well you can do. Anytime that you're stuck, you can either look at the answer for inspiration or keep refreshing the question by simply selecting the star. As you move through the stars, the questions will get progressively more and more difficult up until you get to the 6th star question. So I'm going to give you now just over 5 minutes to be able to have a go at some of these questions. For those of you that aren't able to have this website open in a separate tab, I will put all 6 questions up on the screen so that you can actually do one of each of the different ability questions, and you've got just over 5 minutes. Off you go. Just under 2 minutes left. Okay, if we stop there. Now obviously the nice thing about this website is that following this video you can continue to use it in your own time, and obviously you can actually just focus on a particular level of difficulty, keep refreshing it as many times as you like, and get endless opportunities. That said, you can also choose a really good effective starting point as well, so that instead of looking at only the 1 and 2 star questions, you could jump straight in at the 4, 5, 6 and practice however you like in your own time. Now obviously I'm going to focus on the questions that I've given you, and especially those people that have been working on the questions from the screen. So dealing with those questions then, I've got to rationalise each of these numbers, or at least rationalise the denominator of questions 2 to 6. The first one was I needed to rationalise what could I multiply root 3 by to rationalise it. Well, the answer here was to times it by root 3 and I'd just get 3. For the next one, what would I rationalise the denominator by doing? Well, times it by root 2, so you times the top by root 2 as well. So I get root 2 all over 2. Now this one can't be simplified, although both the numerator and denominator have got 2 in them. The 2 on the top is part of the third, so it's not a common factor in this case. However, when we look at question 3, times in the top and the bottom by root 3, as my numerator, I get 18 root 3 all over 3. And here we've got a common factor of 3 in 18 and 3. So we've got divide top and bottom by 3 would give me 6, and then root 3. Now you could write that over 1, but at this point we don't need to. So moving on to question 4, times in the top and the bottom by root 3. Times in the top by root 3, we've got to put this in brackets, and expanding out the brackets would give us 11 root 3 plus 3, and that would be all over 3. Now I can't do any cancelling with this question, even though the 3 here it's got to be a common factor of 3 in the whole of the numerator in order to be able to do any simplifying. So moving on to the next question, with that one in its simplest form, moving on to the next one, we can times the bottom by 11 plus root 11. So just simply changing the sign on that one. And then we've got 11 plus root 11. Now I suddenly realised that I have not got a calculator, so I'm really going to struggle with 19 times 11, but let's give it a go. I think it is 209. And then add on 19 root 11. As a denominator, using the claw method and remembering that put this in brackets, I've got to times everything in the second bracket by 11 and everything in the first everything in the second bracket by negative root 11. So what do we get? 121 plus 11 root 11 minus 11 root 11, and then negative root 11 times root 11 is 11 minus 11. So tidying up the denominator, the middle two terms cancel out, and 121 take away 11 will give me 110 as my denominator. The numerator remains unchanged because there's nothing I can simplify with that question. Now number 6 makes you feel like an absolute hero when you manage to solve questions like this, because this basically summarizes all the learning from this week in one question. Number 1, how do we rationalize the denominator? Number 2, how do we operate with surds? And then finally, number 3, see if there is any opportunities to then simplify the surds that we've been given. So let's look at this one. With this, we've got to times the denominator by 2 plus root 2, and times in the top by exactly the same thing, 2 plus root 2. It might be worthwhile remembering that this really should be in brackets. This should be in brackets, so that when I'm multiplying the numerator and the denominator by 2 plus root 2, I can see that actually it's a product of two brackets. So using the claw method, 18 times 2 and 18 times root 2 would give me 36 plus 18 root 2. Timesing everything in the second bracket by negative root 18 would give me minus 2 root 18, and then negative 18 root 18 times 2 would actually give me minus root 36. As a denominator, times everything in the second bracket by everything in the first, so we'll start off with 4 plus 2 root 2 minus 2 root 2, and then we'll end up with minus 2. So there's loads of tidying up that we can do here. The first one, and this is where I'm probably going to need a little bit more space, so let's rub off some of these questions, and we'll deal with the rest of question 6 on the left hand side of the screen. So let's have a look at my numerator first of all in its easier format of having space. Okay, so let's deal with a couple of things. Root 18, I can see that could be simplified. The highest square number that goes into 18 is 9. So I could write this as the square root of 9 and the square root of 2. So actually, the square root of 18 can also be written as 3 root 2. Now this is also being multiplied by negative 2. So altogether, if I look at how this could be rewritten, I've got minus 6 root 2. Root of 36 is minus 6, or the root of 36 is 6, so put in the negative sign in front of it. I've also got 18 root 2, which can't be simplified, and I also have 36 at the front. So now collecting together all terms that are like, you've got 18 root 2 minus 6 root 2 is 12 root 2, and 36 take away 6 is then 30, so 30 plus 12 root 2. So there's my numerator, which would be 30 plus 12 root 2. Now looking at my denominator, I had 4 plus 2 root 2 minus 2 root 2 minus 2. The middle two terms cancel out. So now I've got 4 minus 2, which will then mean that my denominator is 2. There's a common factor between all the numbers there. The common factor is 2, and this means I can now divide everything in my numerator by 2 and end up with 15 plus 6 root 2. So, this question then, it is a big one, and I'll just move my screen over a little bit so you can see that there the answer is 15 plus 6 root 2. And if I just put up the NWB website again, and we'll just check that I managed to get all of that right. Yes, hero. We've got all of these answers if you happen to not be able to read my writing. So where do we go from here? We've now looked and practiced the basics. You've got the opportunity of still using this site following the lesson. What I want to do then is look at some exam style questions, because in an exam, how would they be possibly phrased, and how many marks would they be worth? Well, here I've got 3 final questions, and this was actually taken from a past paper where it was worth a total of 4 marks, and it is simply just rehearsing your ability to be able to rationalise the denominator. I'll give you 5 minutes, have a quick go at each of these, and we'll touch base in 5 minutes time to see how well you've done. Okay, hopefully that's given you long enough to be able to have a go at all of those questions. So let's just quickly review them and see how well you've done. So with this question then, what we're aiming to do is multiply both the top and the bottom by root 10. Now typically this is probably only worth 1 mark in an exam. So we'd end up with root 10 over 10, and nothing there can then be simplified. Moving on to the second question, multiplying both the denominator and the numerator by root 15, we would get 3 root 15 all over 15. And the key thing with any of the fractions is to check to see if they can be simplified. So with this one, we can divide both top and bottom by 3, simply because although 3 root 15 is a number, This is being times by 3, and I can see that 15 has a factor of 3 in it, or at least it's divisible by 3. So we can then end up with root 15 all over 5. Moving on to the last one then. With this one, we don't need to do anything too complicated with the denominator like we've seen in some of the other questions. So with this one, we are timesing the top by root 7 and the bottom by root 7. Putting the numerator in brackets, we'll see that I actually need to use the claw method to be able to expand out these brackets. So 5 times root 7 is 5 root 7. And negative root 7 times by 7 then gives me minus 7. Looking at my denominator, root 7 times 7, root 7 is 7, and there we have it. Now typically, like I said, the first one's probably worth only 1 mark. The second one might be as well. Bearing in mind that with this one, you may get an extra mark for noticing it can be simplified. And then the second one, 1 mark probably for the numerator, and then the denominator, and recognizing that here root 7 times root 7 would then give you 7. So in today's lesson, we've been looking at how we can simplify surds by rationalising the denominator. And obviously this sequence of lessons has kind of covered everything you possibly need to know about dealing with surds. I honestly hope that this sequence of lessons has been fairly useful, and I just wanted to finish up by saying that all of the videos are available on my channel, so that if you need to go back and watch any of them again. And then more importantly, please look out on for the next schedule of revision lessons. Thank you very much for watching. Please give it a thumbs up if you liked it, a subs if you loved it. And there is the link again for the software that I've been using in today's lesson that you can carry on using in your own time as part of independent learning.